What is chemistry? Well, remembering our chemistry class, it's the periodic table, titrations, equilibrium reactions, and ionic bonds. Not perhaps the most engaging topics at first sight. And if you've ever been bored staring at reaction mechanisms, you're in good company.
After my junior year in college, I worked in a laboratory and went the entire summer not getting one experiment to succeed.
When I got to college, I found chemistry as taught at Harvard was so awful that I resolved never to touch chemistry anymore.
Roger Chen and Martin Chalfie were awarded the Nobel Prize in Chemistry in 2008 for their contributions to humanity. How do you get from an aversion to studying chemistry to a chemical contribution to humanity? The key is that chemistry is so much more all-embracing than first encountered in the textbooks and the lab.
Chemistry is so insidious, I would say, that you don't notice it often. We are sitting here, and I think probably most of what we are wearing is chemistry. It's hidden, you don't see it in most cases. That's one of the problems. Chemistry is not on the forefront, but it's always there.
Chemistry is that massive part of physics that pertains to the world we live in. In general, people have forgotten or are not aware of how important chemistry is to almost every aspect of their life. They don't even think that when they go to the dentist, the anesthetic that makes their sort of visit pain-free and bearable is chemistry.
On the rare occasions when chemistry does get any attention, it's usually because of some industrial accident or perceived threat from contaminants in our food.
It must have to do with people's experience of chemistry in school, smelly, stinky, and then there's all the concern about pollution that's always labeled chemistry.
But chemistry also lies at the heart of so many other aspects of daily life. Whether it's a question of how to remove carbon dioxide from the atmosphere, or what we can do to make computers process information even faster. Chemistry is the set of tools we need to find the answer. But while studying the processes of chemistry, when your eyes are swimming with formulas, it's easy to forget that most of what scientists define as chemistry has a direct connection with the world.
Today's chemistry is a very broad field. There are chemists who work on what we would call material science. They try to create new materials for building things, but they can also be used, for example, for tissue replacements for an artificial knee or an artificial hip. Other chemists have been awarded the prize for studying atmospheric chemistry, which has great importance in understanding climate change and the ozone hole, how the production of carbon dioxide can lead to global warming. In the last 50 years, there's been a lot of progress in sort of the core synthesis aspects of chemistry. But at the same time, much of chemistry is now directed towards problems in biology.
Since the Industrial Revolution, chemists have been transforming the material world around us. Now, as well as working on solutions to the energy crisis, global warming, and advances in electronics, they are increasingly turning their sights to life itself.
Our best hope of applying physical principles to the world around us is at the level of chemistry. Our best hope of understanding the biological organism and ultimately the form and function of the human body is at the level of chemistry.
That's what we are. We're a test tube in which a huge number of complex chemical reactions are taking place.
Diseases are also tools of learning. And at the end of the day, these are aberrations in chemical reactions, in processes, biochemical processes that are occurring in our body.
This is one of the beauties of chemistry. All the principles you learn in class are tools you can apply to help understand everything around you. Redox reactions and the laws of thermodynamics all work in the same way, whether within an enzyme in a human brain or in a beaker on a lab bench.
The excitement of chemistry is still there in the traditional core areas, but now equally there's excitement in chemistry out on the edges.
If one looks at the advances in condensed matter physics, of making semiconductors, of making solar cells, these are all chemistry.
And that's at the core of chemistry. While physicists strive for the perfect description of the subatomic universe, or biologists endeavour to piece together the workings of life, it's chemistry that holds the power to make something of it, to describe the atomic clockwork of our world, and then see just what we can do with it.
I think today, more than ever before, chemistry is the overarching science, or in some ways the underpinning science.
In physics, we try to understand the world around us at every level. But chemistry is unique in that it creates new materials, new items, new medicines that are useful to mankind and make our lives better.
Chemistry is greater than it first appears. It forms the basis of all of our knowledge of fields as diverse as genetics, solar energy, and nanotechnology. And it equips the curious with a means to explore our world further.
Chemistry is really the queen of the sciences. Chemistry is the common ground for all scientific investigation. If there is any one subject that an educated person should know in the world, it is chemistry.